Grade 8 Math, number 7.2c. This entire chapter is about solving linear equations, and we're doing rational numbers. So this video is about solving real-life linear equations that have decimals. To solve an equation with the same variable on both sides that has decimals, we start by multiplying the decimals by powers of 10 to remove the decimal points. So we explained in the last video, we use the same steps to isolate the variable that were used for solving equations with integer coefficients and constants. We multiply both sides of the equal sign so the resulting equation has the same solution as the original equation. Now, are you confused about integer coefficients and constants? Remember, an integer is a negative or positive whole number. So an integer coefficient, the coefficient is the number in front of the variable, would be like a negative 3x or a positive 3x. See? That's just an integer coefficient. This is a variable term because it's a term that has a variable in it, so its value changes depending on what the variable's worth. That's a constant term because it doesn't have a variable, it's just a constant number, see? So now you know integer coefficient and constant, right? So you're not confused? All right. Tala has 2 aquariums and wants to put them both on a new table. One aquarium can hold 1.3 cubic feet of water, and the other one can hold 1.9 cubic feet of water. The water in the larger aquarium weighs 37.44 pounds more than the water in the smaller aquarium. The maximum weight her new table can carry is 200 pounds. So we need to write an equation with the variable on both sides to represent the situation. Then we need to find the weight of 1 cubic foot of water and if the table can carry the 2 aquariums. All right? So I drew a picture so that we can kind of understand what's going on. She's got this new table and she's got 2 aquariums. One can hold 1.3 cubic feet of water and the other one can hold 1.9 cubic feet of water. And this one is going to hold 37.44 pounds more of water than this one. So if we add the 37.44 pounds of water on this side, then both would be equal. See? This one has that much more, so if we give this side that much more, they'd be equal, okay? So now we have our equation. We have 1.3x plus 37.44 equals 1.9x. We write our equation, and we need to multiply it by a power of 10 to remove these decimal points. Every single term has got a decimal point. This one needs 1 hop to get rid of that 1 decimal point. This one needs 2 to go 1, 2 to get rid of it, and this one needs 1 hop. Now, we have to do 2 hops, which is 10 to the second power, so that there'll be enough hops to get rid of all the decimal points, because they all have to be multiplied by the same power of 10. So now we're going to have, because this one needs 2 hops to get rid of the decimal place, they all need to be multiplied by 10 to the second power, which is 10 times 10. So we're going to multiply 1.3x times 100, and that's going to hop our decimal place 2 spaces, 1, 2. So it's going to be behind this 0 that we had to add as a placeholder. The 37.44 is going to go 1, 2, and it's going to be behind this last 4. The 1.9 is going to go 1, 2, and it's going to go behind the 0 we had to add as a placeholder. So now our numbers say 130x plus 3,744 equals 190x. All the decimal points are gone. Now we can just use inverse operations to isolate the x to one side. So the first thing I do is, I see this is a positive 130x. I can subtract 130x from each side. That's going to create a 0 pair, and that's going to disappear. And 190x take away 130x is going to give us 60x. See? And we drop down the 3744. Now, because 60x means multiplication, the inverse to isolate the x to one side would be division. So we're going to divide both sides by 60. 60 divided by 60 is 1, so that gives us our friend the invisible 1. And 3,744 divided by 60. I did my long division over here, and 60 can't go into 37, but can go into 374 6 times. And I did my long division all the way down, and I got 62.4. Well, that means 62.4 equals x. That's how much each cubic foot of water weighs. 62.4 pounds. Now remember, the table can only carry 200 pounds, and it'll collapse. That'd be pretty scary to have 2 aquariums on there with a collapsing table. So she needs to figure out how much 1.3 cubic feet and 1.9 cubic feet is to this 62.4. So what she did was, what we can do is multiply 1.3 times the 62.4. And we get 82.12 pounds. See? We had 2 decimal hops in the equation, so there's 2 decimal hops in the product. We have 82.12 pounds for this one, all right? Now remember, it said that this one was 37.44 more. So all we have to do is take the 82.12 and add the 37.44, and we get 119.56 for this one. Now we can add the 82.12 and the 119.56 together, and we'll get a total weight of 201.68 pounds together. No, the table isn't strong enough to carry both aquariums. It can only carry 200 pounds, so it's just over. And it wouldn't be worth taking a chance with her pretty fish inside, or whatever she's putting inside the aquariums, that it would collapse. See? So it's a good thing we figured this out for her, isn't it? All right, we could have also just multiplied 1.9 times 62.4 and gotten that answer. But I knew that it was just 37.44 more than this one, so I just added them together. So do you see how we can use linear equations, with or without decimals, to help us solve real-life problems? And it's easier, isn't it? So we're going to go on to 7.2D. We're going to continue talking about solving these linear equations, but now we're going to do it as the perimeter of a rectangle for geometry. We're going to solve a linear equation for the perimeter of a rectangle for geometry. Okay? Very next video, 7.2C. Don't forget, if you're confused about powers of 10, we're in Chapter 7 now. You need to go back to Chapter 2 in this playlist for grade 8 math to 2.1, 2.2, 2.3, 2.4. This is the very beginning, and it tells you all about how to work with powers of 10, positive ones, negative ones, everything is in Chapter 2. Okay? All right. I'll see you next video. Keep up the good work, and I'll see you there. Bye.